Hello, dear student. Um, Thank you very much. And thank you for getting into the class. And here, this is recorded class. This time is 1:10, 1:11 p.m. Your class is at 3 p.m. It's now, when you are listening to this video, it's already 3 p.m. Why I'm doing this? You may guess. I have an emergency job at this time. Maybe at 3 p.m. This is, I will have to go to hospital. My mother-in-law, she's there. She's in trouble, serious trouble. I already went there in the morning and I'm going again there at this time. And the mishap happened already in the last day. And we got a test on titration. And when you were taking the test, then I was sitting over there on the chair before you, and I got slept. So this is why we couldn't continue the class after your test that we were supposed to. So let's see here. Thank you. And in the test, about the test, 2 students did not send the test copy, test script. And this is not optional. Students have to, if they want to go on with us, test is mandatory. So this could be a chance. We can give them a chance that if you did not send this paper, these 2 students I'm talking about only, they have to send the script by today. If they can make this by today, we will consider them to go on with us. Okay, after this, we start. This next topic now is salt preparation. Salt preparation chemistry laboratory. If I talk about salt, you remember the table salt that we eat every day. We make curry with the salt, and if salt is not added to any curry, we cannot eat them, we cannot take them, because that doesn't taste good. So that is a salt. Yes, that's salt, table salt. Sodium chloride is a salt, but there are many salts. The idea of salts you already have, because you got the reactions of acid alkalis, and you got many exercise of writing the equations. I told you the simple way was first write the salt, formula of the salt, then think what other things to be produced in the reaction. So you got good exercise. Yeah, I'm really happy that you really got good exercise in the equation, writing equations. And then salts. And this table salt I was talking about, we get from seawater. We don't have to make this salt in factory or in industry. We naturally get this salt, like oxygen. Okay, the oxygen we get naturally we get oxygen. We inhale, exhale every day. We are thankful to the Almighty that we don't have to buy them. But if you are in danger, in some cases, suppose corona disease, in some corona disease, most of the people having corona, they don't understand even that they have this. The villagers, the hardworking people, they don't feel even that they got corona. Only fatty people or sick people and mentally scared people, they have this serious problem. Okay, oxygen, I was talking about. Oxygen is available in nature, but when they're patient, they cannot breathe in the natural oxygen. They need somewhat concentrated oxygen. Okay, so what the factory do here, they collect the oxygen from nature, or they make with reactions. So 2 ways you can prepare oxygen. One is somehow separate from air. This is somewhat difficult process. Another is making up oxygen. This is simple reactions. From water, oxygen can be made by electrolysis. You yourself can do this in your house. Okay, but that's that. If you make that oxygen in a house, that may not be good for medical purpose, because many other things also there. Okay, come on. So I was talking about salt, and oxygen is an example. Salt we get from seawater. The farmers, we call them farmers, the people who are involved in extracting salt from seawater, they're commonly known as farmers. The farmers get the seawater and evaporate, and get the salt. Then in the factory, the salt is purified and crystallized. So finally, we get the salt. This is the salt, table salt. I was talking about that. Many salts, and when we talk about salt preparation in chemistry laboratory, that doesn't mean extraction of salt. Here, salt preparation is different. How is that? You have to carry out a reaction. For that salt preparation, you will have to carry out a reaction. I mean, you mix two chemical substances together, they react, and they produce salt. Understand? So this is the case here. And here are 4 points to be mentioned. Very important 4 points. Listen attentively. One, when you will prepare salt or describe to prepare a salt, then there are 4 points. One, the first one is you have to carry out a reaction with certain chemicals, with selective chemicals. You have to carry out a reaction. You mix them together, that reaction that produces salt. This is not natural salt. This is through a reaction. Number 2, the salt you make, okay, then number 2 is separate. The salt is prepared already. When you mix chemicals together, salt is prepared. But there's some other things, there may be some other things with the salt, along with the salt. What you should do is separate the salt. Okay, this is number 2. Number 3, you will have to purify the salt. The salt must be purified. Okay, when you describe making salt, then this is the condition. Third condition is you will have to purify the salt, should be pure. Nothing should be mixed with the salt. And number 4, the salt should be good looking salt. Good looking salt means go to the kitchen and see your salt, table salt. The white, fine, refined, crystalline salt. The salt you make should be not like muddy or powdered salt. There must be crystalline salt. So there's 4 points. If you're attentive, you can now recall the 4 points of making salt. I repeat this, then you try yourself. First is the salt is not natural. You will have to make the salt. You will have to carry out a reaction to make the salt. This is 1. Number 2, the salt should be separated from other substances in the reactions, a reaction mixer. Number 3, the salt must be purified. You will have to purify the salt, pure salt. Number 4 is the salt should be good looking. It's a white crystalline, or sometimes they may not be white, colorful, but they should be good looking crystalline salt. These are 4 points. So now I told those 4 points twice, and I hope you're attentive. Here you give a pause of the video for a few minutes or seconds, and then recall the 4 points. Thank you very much. We're back again. I also given a pause, and if you can remember, it's a very good. Looks that you are attentive, or if you have little problem or distracted, cannot remember, then go back rewind the video for a few minutes and listen the 4 points again. Okay, it's very important. So now we start the next point, and the next point is salt preparations have ways. There are many salt, and they're different. In many ways, salts are different. Suppose some salts are soluble. Soluble means the table salt, sodium chloride that you eat. You put some salt in water, what would happen? Dissolves. So what we call the salt? Soluble. So there are many salts like sodium chloride are soluble. There are many salts like sodium chloride are soluble. And salts are also insoluble, like sand. Sand is not salt, but I say like sand means if you put some sand in water, you will see that that doesn't dissolve. Okay, so again, salt preparations have ways, and the ways depends on whether salt you are going to make soluble or insoluble. If it's soluble, the method is different, or if there's an insoluble, other method. So before you go for describing or studying how you will make salt, initially you will have to know or able to identify the salt soluble or insoluble. So I'm going to show you here note. This is the note you see here. At the beginning, you see here two types of salt we get here. Soluble salt and insoluble salt. Read which salts are soluble. You get a minute to go through only soluble salt. Thank you, student. I'm back, and I hope you already read this. Here it says all salt, any salt with group 1 metal. Group 1 metal means basically sodium, potassium, lithium, and there are some more metals are there. Group 1 metals. Basically, you will need this 3: sodium, potassium, and lithium. And with these 3 metals, if you get any salt, suppose sodium chloride or potassium chloride or lithium chloride, or could be sodium sulfate, potassium sulfate, lithium sulfate, or could be sodium nitrate, potassium nitrate, or could be sodium carbonate, potassium carbonate. And these are all salts with sodium, potassium, and lithium. They are all soluble. I mean, if you get these 3 with any salt, any compound, they dissolve in water. Okay, it's very simple. Ammonia, salt of ammonium is ammonium salt. Okay, this is basically like ammonium chloride or ammonium sulfate or ammonium nitrate or ammonium. They're all soluble. So like this, if group 1 present, whether the other substance, I mean anions, could be from any ion, any anion, soluble. Like this, you get another like this. If nitrate is there, okay, nitrate is there, they are soluble. Any metal could be with nitrate. Calcium nitrate, sodium nitrate, potassium nitrate, any metal So this first one was about metal, group 1 metal, whatever the anion is. And this says if nitrate is there, whatever the metal is, if nitrate alone is responsible to make the salt soluble. And if this talk about group 1 metal, group 1 metal is there, the salt will be soluble, must be soluble. And about chloride salt, chloride salt means salts of hydrochloric acid. From hydrochloric acid, we make chloride salt. Chloride ion is there. If chloride ion there, except two, you just get two, except two. These are silver chloride and lead chloride. Except these two are not soluble. Except these two, all other chloride. I mean, with silver metal and with lead metal, chlorides are insoluble. And other than silver and lead, if you put here any metal, sodium, potassium, aluminum, zinc, etc., etc., they will all be soluble. So chloride mostly soluble, nitrates all soluble, group 1 metal all soluble, nitrate all soluble, chloride except two. And sulfate like chloride, here just two exception, barium sulfate and lead sulfate here. Here you got lead, you also get lead chloride and lead sulfate. So lead is somewhat a sign of insoluble, but lead nitrate would be soluble. Why lead nitrate soluble? Because all the nitrate soluble. Okay, got this. And here's silver chloride, and so far we've been discussing about soluble salt. Now it's insoluble salt. So you may give here a pause and think and listen this again for a few minutes, then go to insoluble salt. All the carbonates are insoluble. All the carbonates are insoluble, but except group 1 metals, because you got here, if group 1 metal present with any anion, they are soluble. This is first, sodium, potassium, lithium. But if carbonate present, this is the general statement. If group 1 metal present, soluble. If carbonate present, insoluble. But if you get a compound with group 1 metal and carbonate, what would happen? What should happen? What do you think? Group 1 metal present and carbonate is also present there. That would be soluble because group 1 metal there. So finally, you may have puzzle. You may be puzzled about so many things, so many information. Should you remember all of this? No, just simplify. So make things simple. One, just think about insoluble salt. Just think about insoluble salt, not about soluble salt, because you get here many statements about soluble salt. To remember, just think about insoluble salt. What are this? Whole carbonate. Carbonate is this. All carbonates and these four. So this is simple. So if you get a compound with carbonate, that's likely to be insoluble. And if you get these four examples, two of them with lead chloride and lead sulfate. Formulation is very important, no? To remember formulation, lead chloride, lead sulfate. But I already mentioned that if think about carbonate, group 1 carbonate are soluble. Group 1 carbonate are soluble. So if you just think about insoluble salt, this is not a burden to remember many things. The fact will be very simple. Only carbonate and only these four examples. Certainly you should be aware of the group 1 carbonate. Okay, so this. So these are about soluble salt. Earlier you learned about types of salts, other way, that chloride salt. When you make salts from hydrochloric acid, the salt contain chloride with metal. Suppose zinc chloride, aluminum chloride, potassium chloride, chloride salt. And the salts made from sulfuric acid, you call them sulfate salt. Zinc sulfate, aluminum sulfate, potassium sulfate, lead sulfate, etc. These are all sulfate salt. Or similarly, carbonate salt, carbonic acid. Okay, this you learned earlier. And here you get soluble salt or insoluble salt. And also we need to recall, you learn acid. What is an acid? The compound that gives H+ ion in water. The hydrochloric acid, nitric acid, sulfuric acid. Okay, some are weak acid, some are strong acid. And then base could be metal oxide or hydroxide. Bases are metal oxides or hydroxide. Okay, metal oxides or hydroxide, which neutralize acid. This you got in a test, short test, that what is a base and why is these compounds are base. You got a question like this in the test. That there should be metal oxide or hydroxide which neutralize acid. And for alkalis are only hydroxide. But here's also a condition. The hydroxide is soluble in water, is dissolved in water, which are soluble in water. Alkali, like acid gives H+ ion in water, and alkali gives OH ion in water. Here's strange thing about water. Water has many dissolved ions. Water itself has many dissolved ions. These are called minerals. They are not part of water. Suppose sodium chloride is also with water. Calcium nitrate could be with water, like this, the natural water. But they are not part of water. There are some impurities. If you think about pure water, just water, nothing with water, that also contains two ions, H+ ion and what? OH ion. This is an amazing property of water, that water, when many molecules together, well above 10,000 together, just one of them, one water breaks down, not the 9,999. Just one breaks down to give two ions. Which two are the ions water gives? This is water. If it breaks down, it gives two ions. But this is a very rare case, remember. Water doesn't have this much H+ and OH ions. And H+ ions means acid, and OH ion means alkali. But water, though, contains both the ions, not acid, not alkali. Why? Because this says I'm acid, this says I'm alkali. And when they're equal, then nothing. Not acid, not alkali. So what is not acid, what is not acid? Neutral. Okay, neutral. So after this discussion, now we're gonna have some work. What is the work? Some question with some exercise examples. There you will get, I show you first the question. Okay, this is there. You may see this again. That's wise. Pause and see. Repeating makes your memory stronger. Okay, this is not for chemistry, for everything. When I was student, I studied this. I discovered some tools, psychological tools, which is the first. When you study a new topic, this could be of any subject. that may feel difficult. Difficult means you don't feel good initially. And you may remember your past that many times this happened to you, that you started something which you felt difficult, but now or later you think that they are very easy. So what is difficult today, that would be easy tomorrow. This is a basic principle of study you should always remember, because in different classes you will learn different things. You keep up learning different things. This is one. Number two, repetition. When you get a hard topic, difficult topic, you read or you listen, and next day don't try to learn this type of things in a single day. Better you get another day. Best is the next day. So you read today and you read tomorrow. You read today, maybe you understand something or maybe you don't understand. But if you read the same topic tomorrow or next day, you will be surprised to read this that you understand. Better you understand. Because when you put an information input into your brain last day, it works automatically. When you even sleep or work or eat, brain works automatically with the input you put that in last day. Maybe you didn't understand, but brain got the information. It automatically processes the data. So next day when you read again, you understand better. So this is how repetition works nicely, or makes things easier. So now I repeat this and solve this question. This is our job now. Here, see, the following formula represent some chemical substances. Here, many chemical substances you see here. Okay, many chemical substances you see here. Some are acids, some are salts, some are bases, some are alkalis. Okay, so list the formula of the compounds. You need to pick up the compounds which are bases. So which are bases? Out of this, some compounds are bases. You will write here the formula and send me. And then acid. Which compounds you think are acid? Write their formula here, acid. When all the acid written, you send me. Chloride, salt. Chloride salt means salt you get from hydrochloric acid or chloride salt. Sulfate salt, the salt you get from sulfuric acid. Water soluble salt, the salts which are water soluble. This is just learned. Water soluble salt. All nitrates are soluble. If nitrate present, soluble. If group 1 metal present, sodium, potassium must be soluble. Ammonia present, ammonium salt soluble. All chlorides are soluble except two. These are lead chloride and barium chloride. And with lead, another salt is lead sulfate is also insoluble. And then you got their barium sulfate insoluble. And carbonates are insoluble. Generally insoluble, but not the group 1 carbonates. So this is recalling, and let's apply this and write. Okay, so what you need to do now, you don't need to copy the options. Okay, students, you don't need to write the selected part. You will write the lower part. Here, write them and pick the formula above. Pick the formula above and send me. So what I told at the beginning, to start, before you go for starting salt preparation, you should know the salt type of salts, because we have methods, different methods based on types of salt. So if you're clear about types of salt, if you know clearly the salt is soluble, the salt is insoluble, this is a very simple fact. Then the salt preparation, you will feel salt preparation easy. Okay. Well, thank you very much. I will try to join live whenever I get time. I say that I'm going to hospital at that time because she's under treatment, and at about 2:30 after 2 p.m. I will have to receive her. So that's the problem at that time. I'm free now, but that job is not now. This is maybe clashing with your class time. So this is how we did this, and you maintain time. You must maintain time that you send this now. Okay, now, because if I get chance, I may call you at when at maybe 2:30 or 2:45 if I get chance. Okay, I will call you, give the call in Zoom. You all get into the class, but beforehand you finish them and send me. So till then, thank you very much. I'm uploading this video for you, but this you will get only in your class time at 3 p.m. So I'm not informing you right now before 3 p.m. that I'm unable. Okay, thank you very much. Take care. Assalamu alaikum.